Subscribe to our YouTube channel and press the bell icon to get the latest updates.
From microbes that call Da Vinci's paintings their home to the discovery of a new blue-colored mineral in Russia, on this edition of Scientifics, we bring you the top science stories of the week from across the globe. For the first time, scientists have delved into the microbes living in several paintings of Leonardo Da Vinci, revealing unseen traces of DNA left on these works of art. Researchers analyzed 7 different drawings of Da Vinci using an innovative genome sequencing technology. Overall, researchers found that bacteria dominate over fungi in these pieces. Until now, fungi were thought to be a dominant community in paper-supported art. A high proportion of bacteria was most likely introduced by intensive handling of the drawings during restoration works, or may have come through flies and their excrements a long time ago. There was also presence of a large amount of human DNA. These did not come from Da Vinci himself. Rather, they are likely to have been introduced by the restoration workers over years. It is important to understand the microbiome present on valuable works of art, because only then can we understand the best way to preserve these works. Meanwhile, in a stroke of luck, a camera aboard a research ship was able to capture a footage of an extremely bright meteor crossing the sky in front of the ship and then breaking up over the ocean. The meteor, which was bright green, was spotted by the bridge crew and reported to the science staff on board RV Investigator, a research ship owned by Australian government's Commonwealth Scientific and Industrial Research Organisation. The meteor was captured by the ship's live stream camera, which beams live vision from the ship 24/7. It crosses the sky directly in front of the ship and then breaks up. Over 100 tons of natural space debris enters Earth's atmosphere every day, but most of it goes unseen. When a meteor enters the Earth's atmosphere at high speed, it is the friction of the rock with the atmosphere that makes them burn. At the time the vision was captured, the research vessel was in the Tasman Sea, about 100 kilometers south of the Tasmanian coast. Also this week, scientists have recreated the family tree of the Milky Way galaxy by analyzing the properties of globular clusters using artificial intelligence. Globular clusters are dense groups of up to 1 million stars that are almost as old as the universe. The Milky Way hosts over 150 such clusters, many of which formed in the smaller galaxies that merged in to form the galaxy. Astronomers have suspected for decades that the old ages of globular clusters would mean that they could be used as fossils to reconstruct the early assembly of histories of galaxies. Using a computer simulation, researchers were able to relate the ages, chemical compositions, and orbital motions of the globular clusters to the properties of the galaxies in which they formed more than 10 billion years ago. The simulations also revealed a previously unknown collision between the Milky Way and the galaxy which the researchers named Kraken. The findings allow the team of researchers to reconstruct the first complete merger tree of our galaxy. Over the course of its history, the Milky Way cannibalized about 5 galaxies with more than 100 million stars and about 15 with at least 10 million stars. In high school textbooks, human chromosomes are depicted as a distorted X shape. But now, new 3D images show that the human chromosomes look very different. Researchers have captured high-resolution 3D images of human chromosomes which contain our DNA. The team used a new method to image the structure of chromosomes. They built a chromosome map from both wide-lens images of all 46 chromosomes and close-ups of one section of one chromosome. The images reveal insights into how genetic codes are translated into proteins. In fact, the team now believes that the structure of the chromosome may influence its functions. The research also indicates that no 2 chromosomes look the same, even in cells that are otherwise identical. To discover what each chromosome looks like in every cell in the human body, the work of 3D mapping chromosomes will have to be expanded to other labs. Also this week, scientists have discovered a new mineral called petrowhite, which occurs as blue globular aggregates of crystals with gaseous bubbles in Russia. For more than 40 years, researchers have been studying mineralogy in the Kamchatka Peninsula. Unique features in the region were formed after two major volcanic eruptions in 1975-76 and another one in 2012 and 2013. The chemical formula of the mineral is Na10CaCu2SO4 The copper atom in the crystal structure of petrowite has an unusual and very rare coordination of 7 oxygen atoms. Such coordination is characteristic of only a couple of compounds. The mineral has a porous framework. The voids are connected to each other by channels through which relatively small sodium atoms can move. The scientists have therefore established that the structural type of petrowite is promising for ionic conductivity and can be used as a material for sodium-ion batteries. This is Mohana Basu for The Print. For more, visit theprint.in and follow us on social media.